Hello everyone, and today we'll be going over SI based units for A-level physics. We'll cover everything you need to know, including the 6 base units you need to know, derived units, everything else. Alright, so you might be wondering, what is an SI based unit? Well, SI units are a set of international units that all the different countries agree on, so we can measure these quantities and not get confused when we're talking to each other. Right, but we don't really need to know that for physics. We just need to know what they are. Alright, so number one, we've got mass. You probably already know that mass we usually measure in kilograms. Length we usually measure in meters. Time is usually seconds. Current is usually measured in amperes, or amps for short. Temperature, Kelvin. You might be thinking this is degrees. We'll go through the difference between those in a further video. And amount of substance, if you do chemistry, if you did chemistry GCSE, you know, moles. Alright, so the word base means that these units cannot be broken down further. Hence, this means that they form the foundation of physics. So every future quantity we'll look at, it's possible to break it down into these different categories. So now we'll be going over derived units, and essentially what this is if we have a quantity such as momentum or density, we don't know the units, we can look at the equations and break it down from there. Okay, so basically we see that momentum, which is represented by P, is equal to the mass of an object multiplied by its velocity. Okay, so we know the SI units for mass. What are the SI units for mass? Kilograms. But we don't know the SI units of velocity, so we need to get the equation of velocity and break it down further. Okay, so velocity is equal to displacement over time. Don't mistake this with seconds. Okay, S in physics represents displacement. So we have displacement over time. Displacement is measured in meters because it's a form of measuring length essentially, and time we know is measured in seconds. So velocity can be represented by meters divided by seconds, or meters per second. This -1, ms -1, is the same as writing this. Okay, so you don't need to get confused. Alright, next. Oh, sorry. So that means we need to find the whole derived unit of momentum. So that's mass, kg, times velocity, meters per second. We multiply them and we get kilograms meters per second. So that's the base derived unit of momentum. Okay, now we're going to go for density. So density is equal to mass over volume, and this is a pretty easy one because both of these can already be measured in SI based units. So for mass, we know from there it's kilograms, and volume, we know that volume is measured in meters cubed. So if we're doing mass divided by volume, we get kilograms per meter cubed, or we can write it like this: kilograms per meters cubed. Right, so now we have prefixes. Prefixes are a way of making writing really large or really small numbers a lot simpler. So we have them in descending order. So we have the greatest is tera, which is 10 to the 12, giga is 10 to the 9, mega is 10 to the 6, kilo is 10 to the 3, centi is 10 to the -2, sorry I made a mistake there, milli is 10 to the -3, micro is 10 to the -6, and nano is 10 to the -9. And then here we have two examples. So let's say we had a question, we worked out our answer was 1,000 grams, but the question wants to answer in kilograms. So we can see that kilo is 1 times 10 to the 3, which is the same as 1,000. So 1000 grams is equal to 1 kilogram. Same aspect here. Let's say we get the answer as 1 million volts, but maybe that's too long. We want to write it in a simpler form, so we can see that mega is 1 times 10 to the 6. So you have 1, 2, 3, 4, 5, 6 zeros here. So we can write 1 million volts as 1 megavolt. And we'll go through how to convert between these in a further video.